If you ever feel lost in algebra and wonder where to begin, let me make it simple for you. My name is Mr. Gordon, and I'll help you learn the basics you need to tackle Algebra 1 with confidence. So jumping right into it. So first things first, you want to understand expressions and equations. You're going to get that all throughout algebra, and you just want to know the difference between the two. An expression is a mathematical phrase that combines numbers, variables, and operations, but does not include an equal sign. I'm actually going to highlight that because that's going to be important. Does not include an equal sign. So in my example here, we would just have 3x plus 5. That's just something very simple we'll see in our classes. An equation is a mathematical statement that shows two expressions are equal using an equal sign. And I know we've seen them already, but this is just putting a term to what we already know. So here, just like we did for expression, we have a 3x plus 5. In order to make that into an equation, we would just add that equal sign over here. So this expression is now equal to 11, making this now an equation. So in the practice problems that I have for you guys down below, we have 4y minus 2 equals 10. Now, if we're wondering whether or not that is an equation or an expression, we would just have to go back to our definitions. Now, we know that equations does have an equal sign, so you can kind of use this as a trick. So equation, equal sign. So does this one have an equal sign? Absolutely. So I'm actually going to write that here. Equation. This changes the question a little bit, and we should be on the lookout for these equal signs. So for B, this does not have an equal sign. So according to our definition, instead of an equation, this is going to be an expression. So I want you guys to pause the video right here and kind of go through C through F to make sure you guys understand what it means to be an expression or an equation. I'm going to go ahead. C, we know, does not have an equal sign, so this one is also going to be an expression. D has an equal sign, so this is going to be an equation. This one also has an equation, E. E also has an equal sign, so we know that's going to be an equation as well. And F does not have an equal sign, so that's going to be an expression. Looking good so far. Next up, we want to know what variables are, coefficients, and constants. We may have learned this in our classes already, but just to review, variables are simply letters. And I'm going to actually fill in the blanks here. Letters. Okay, so anytime you see a letter, that is a variable. Next up, we have constants. Constants are terms without variables. Okay, and coefficients. Coefficients are numbers in front of the variables. So these are pretty simple. And the more you see it, the more you'll just understand and just know what it is. So here, in our practice question here, it says, in the expression 3x plus 5, identify the variables and the constants. So here, according to our definition, the variables are simply the letters. So it just wants to know what letters we have here. And we know that the only letter we see is that X. So I'm going to put an X here. Now, the constants, according to our definitions, are the terms without variables. So it's kind of the numbers that are just by itself. In this case, the only number that's by itself without any letters is this 5. So our constant is going to be a 5. And there we have it. Moving on to B, in the equation, 4y minus 2 equals 10, identify the variables and the constants. So here we have an equation, and we know from the section before that equations have that equal sign. We're going to do the same thing. I'm going to do my variables first. I'm looking for wherever the letters are. And the only letter we have is y, so I'm going to put a y here. Now for constants, we're looking for the letters. For constants, we're looking for the numbers without letters. And in this case, we have two constants, -2 and 10. -2, and I'm just going to put a comma, 10. And yes, I did just take the sign that's in front of that 2 there. All right. For C, we're given a polynomial, and a polynomial is just an expression that has more than one term. And it says to identify the coefficient of x to the 3rd power. Now, if we're looking at our definition over here, coefficients are the numbers in front of the variables. So all I have to do is locate where my x to the 3rd power is, which is right here. And then I'm looking for the number in front, which is going to be 5. So I'm going to put that 5 right here. And we're going to do the same thing for the other ones. I'm looking for the coefficient of x squared. And again, I'm just going to look for x squared and look at the term right to the left. And in this case, like we did in the other one, I'm going to take the sign in front. So this is going to be -2. And then our last one says to identify the coefficient of x. I'm going to do the same thing we did before. I'm going to locate where that x is, and I'm going to look at the number directly in front of it, which is going to be 7. So I'm going to put that 7 right here. And boom, we're good to go. Now, D has something a little similar. We have another polynomial. It says to identify the coefficient of x to the 5th power. Again, I'm going to look for x to the 5th power, and I'm going to take the number that's right in front. So we have a 4 here. Identify the constants. So here, again, we're looking for the number without a variable. And in this case, it's going to be our 2. Our 2 doesn't have a letter next to it. 2 goes there. And then identify the coefficient of x. Just like we did in the last question, I'm going to locate where the x is and then write the number that's right in front. And here we have it. We have all of our variables, coefficients, and constants. Next up, this is going to be a big part of Algebra 1. We have simplifying equations. So here, I put these 2 key notes over here. You want to always isolate the variable by transposing. And transposing is just moving, and let me highlight it, moving a term to the other side of the equal sign. Okay, and we'll see a little bit of what that means just now. And then when you're transposing, you always want to be sure to use the opposite or the inverse operation. Those 2 are key to solving linear equations. Okay, so for A, I want to make sure that my x stays on one side and then all of my constants stay on the other. There's only one thing we have to do to isolate the x. And what I'm going to do is circle this 5. Let's actually use another color. And transpose it to the other side. Now remember, anytime we're transposing, we want to make sure that we're crossing that equal sign. And here we are. We're going across the equal sign. And I want to make sure that I'm doing the opposite. I always like to circle my term that I'm transposing with the sign in front because that helps me determine what operation to switch it to. So because this is addition, the opposite is going to be subtraction. So I'm going to actually subtract 5 on both sides. If I bring everything down, my x is going to come down. I'm going to have x. 5, positive 5, minus 5 is going to get us to 0. I normally cross that out. Then I'm going to bring down my equal sign. And then I'm going to combine this. So 10 minus 5 is going to equal positive 5. So we can say here, and let me move this over, x equals 5. I'm going to box my answers, and we are good to go. For B, we're going to do something a little similar. I have a z here. It's okay if it's not always x. And I'm asking myself, what do I have to move so that my variable is on one side of the equal sign by itself? And it's that -7 that's in the way. So I'm going to circle -7. I'm going to draw my arrow to show that I'm transposing to the other side. And because this is a negative, the opposite is going to be positive. So I'm actually going to add 7 to both sides. And just like last time, I'm going to bring everything down. So we'll have a z, -7 plus 7. We can cross that out. It becomes 0. And a good tip is to know that you're doing this right. You want to always make sure that whatever you're transposing, when you're combining it, it adds to 0. So this one added to 0. this one added to 0, because that's the only way that we can get rid of it on this side. Okay, so I'm going to bring down my equal sign. And then I'm going to do 3 plus 7, which is going to equal 10. Let's box our answer. We're good to go. Moving on, we'll have something like this. We have a 5a plus 2 equals 17. So now we see a lot of different things. This is not the same as the other two questions that we had, but I still want to isolate my variables. So here my variable is a, and even though the a is attached to that 5 right now, there still is something that I can move to the other side, which is going to be this positive 2. And again, because it's positive, I'm going to subtract on both sides and then bring down everything else. So I'm going to have a 5a equals, because remember we can cross this out. And then I'm going to combine 17 minus 2, which is going to get us a positive 15. So now we can see that the a is still not by itself. And I even put it in red, that 5 is kind of in our way. So this key right here, we're always using the opposite inverse operation. That's going to come to play here. So I always like to say that this 5 is connected to the a, or the 5 is married to the a by multiplication. And the opposite of marriage would be divorce. So I always like to say if they're married by multiplication, we divorce by division. So all I'm going to do is divide both sides by a. All I'm going to do is divide both sides by 5, and that'll get rid of this right here. That'll divide to 1, so I can bring down a, and then we have 15 divided by 5, which is 3. Let's box our answer. And you can always check to make sure that your answer is your answer by substituting it back into your original equation. Okay, so if I were to substitute, I would get 17 equals 17. And that's a good check for our work. Moving on. This one, a lot of students hate to see fractions coming, but it's really not that bad. So right here we have, and I can even write it different. Anytime we see a fraction, division is implied. So here we're actually dividing. And we know that the opposite of division is multiplication. So I'm actually going to write it this way. X divided by 4 is equal to 3. And what I want to do is get the x by itself. So I'm actually going to circle this whole thing. Let me use my other color. I'm going to circle this whole thing. I'm going to bring it to the other side. The opposite of division is going to be multiplication. So all I'm going to do is multiply by 4, multiply by 4. Then we'll have x. We know that 4 divided by 4 is 1. I don't have to put the 1 here. And we know that 3 times 4 is 12. Perfect. And let's cross that out. Let's box our answer. We are good to go. So as long as you're using these two keys, transpose and always use the opposite inverse, you are set. And there we have it. This is the basic, these are the keys that you need to do well in Algebra 1. Algebra is all about solving problems like budgeting your allowance or calculating time for a road trip. Once you understand these basics, you'll have a solid foundation for everything else in Algebra 1. If you have any questions about Algebra 1 or you want me to cover specific topics, please let me know in the comments below. I also left a link to a shared Google Drive if you wanted access to this worksheets or worksheets like these. I hope this helps, guys, and I'll see you later. Bye. I also left